Welcome to this Sunrise webinar on relevant subsystems to validate connected and automated mobility systems. My name is Julie Kastemans from Ertico ITS Europe, and before I introduce our speakers, I would like to mention a few practical information points for this webinar. First of all, the webinar is recorded, and the recording and presentation slides will be shared on the Sunrise project website after the webinar. Then we will take your questions in writing only at the end of the two presentations. So use please the question pane in your GoToWebinar interface to raise your questions during the webinar. And finally, if you need to communicate with the organizers during the webinar, please use the chat pane in the interface. And now to our speakers and agenda for this webinar. So first of all, we'll have a short introduction to the Sunrise project and to the activity and working area in the project responsible for verification and validation simulation framework for CCAM systems. This will be done by Bernhard Hillbrand, who is a senior researcher at Virtual Vehicle. And then we'll have Anders Thorsén, who's senior researcher at RISE Research Institutes of Sweden, presenting the first related results to this working area of the project, and that is the relevant subsystems and requirements identified for harmonized CCAM verification and validation simulation framework. So first, over to Bernhard for the Sunrise project introduction. Bernhard, the floor is yours.
So thank you. Hello, my name is Bernhard Hillbrand from Virtual Vehicle, and I will give you an introduction to the Sunrise project overall and also to Work Package 4. But before we start, let me provide you with some context to better understand the reason for undertaking the Sunrise project. So the context of the Sunrise project is safety assurance of automated vehicles, which is a crucial factor for their successful adoption and the deployment in society. And automated vehicles must be reliable in every possible driving scenario. This requires a strong safety argumentation, which still remains a significant challenge worldwide. For higher levels of automation, so case-by-case validation testing is not feasible due to the high number of scenarios involved, and public road validation is another option, but since the conditions are uncontrollable and this option is inefficient and therefore also expensive. And for that reason, a mixture of physical testing and virtual testing has emerged as a promising approach. Virtual testing allows for a cost-effective testing of large scenario volume, but the reliability of the test results is often compromised. So worldwide, several initiatives have started to develop test and assessment methods for automated vehicles, applying a scenario-based approach and combining both physical and virtual testing. Although automotive stakeholders generally seem to agree on this overall approach, the current situation is leading to silo solutions. So the lack of a common approach is a problem for the large scale and the safe introduction of automated vehicles in our society. And it is for this reason that the Sunrise project started, and it aims to establish a common safety assurance framework, interconnecting the silos and making them collaborate in a harmonized way. So Sunrise stands for Safety Assurance Framework for Connected and Automated Mobility Systems. But this is a quite abstract and intangible topic. So to help you visualize the safety assurance framework, being developed in this Sunrise project, we created this image here. It shows the different types of stakeholders that each have their own interests in the framework. It also shows possible questions that each of these stakeholders want to get answered by the framework. For example, vehicle developers are likely to ask what scenarios they should test their automated vehicles for. Certifiers will want to know how they should assess the safety of automated vehicles. Researchers might want to know how to compare the test results to those of other researchers. And tool developers might ask how they can make their tools fit or interoperate with those of other providers. And the Sunrise Safety Assurance Framework aims to provide answers to all these questions. It provides these answers with the method, toolchain, and data framework that will be developed and demonstrated in Sunrise. And it does not operate independently. Instead, it cooperates with many similar initiatives around the world in the field of CCAM safety assurance, for example, by aligning its components with those of twin projects like V&V methods or Sakura. Or also by drawing contents from related scenario databases like Streetwise or SafetyPool. This slide here shows the general approach or work plan that is applied in the Sunrise project. Again, you can see a central role for the safety assurance framework. And as shown in the upper left part, this framework is based on several methods, a tool chain. For example, a method for scenario selection and allocation, and tools for physical and virtual evaluation. And as shown in the upper right part, another important component is the data framework with its structure and governance mechanisms, as well as an ontology laying the foundation for querying and interoperability. As you can see in the center part of this overview, the safety assurance framework will be put to the test by a series of relevant and realistic test cases. The development of the method, the toolchain, and the data framework does not start from scratch. So it is based on already existing safety assurance frameworks and related initiatives, including the predecessor project Head Start. And the test cases are derived from a variety of CCAM systems and use cases, including urban and highway driving of passenger cars, but also automated parking of freight vehicles. The bottom part of this work plan shows the technical results and demonstrators, including a CCAM safety assurance method and toolchain, but also an interactive user handbook. And together with the twin initiatives from other parts of the world, as I said, for example, V&V methods or Sakura, the Sunrise Consortium actively engage with external stakeholders, such as vehicle safety bodies like UNECE or Euro NCAP, and also standardization entities like ISO, SAE, or ASAM. And this engagement aims at the adoption of the project results by these external stakeholders. So the Sunrise project consists of 21 consortium partners from a variety of European member states. The different types of stakeholders that each have their specific interest in the safety assurance framework are reflected in this consortium. So as this slide shows, the Sunrise Consortium includes entities from the areas of research, technology development, tool development, and certification, which all corresponds to the main stakeholders interested in the Sunrise results. To close the introduction of the Sunrise project, you can see here a group picture with some of our members from the last General Assembly meeting in Athens back in September. So this is for the general project introduction. So next I will give you a short overview of work package 4, which is called CCAM V&V framework, before we then continue with the main topic of today's webinar. So in work package 4, we have defined some objectives that explain the story of the work package quite good. So first, we needed to identify the relevant subsystems of a simulation framework, here marked as objective 2. And this is the work you will hear from in a few minutes by Anders Thorsén. We then took the use case requirements that were defined in work package 7 and mapped them to the subsystems to specify the subsystems requirements. This is here marked as objective 3. The next step is then to define tools, open source as well as licensed products that fulfill the defined requirements. And in another step, individual partners design, develop, and validate the simulation framework. So that means most of the work in work package 4 is about virtual testing, but there is also a part that looks at hybrid and real-world testing, assessment, and validation approaches. So work package 4 was the last work package that started in this project, and so far progress on the objectives 2 and 3 has been achieved. So work package 4 identified the relevant subsystems as well as some optional subsystems and reported these results in the deliverable 4.1, which is publicly available on the Sunrise webpage. And also, we identified the use case requirements, and currently we are mapping those onto the specific subsystems. So the results of that will then be presented in deliverable 4.2. And this slide shows a short summary of the results in work package 4 so far. At this point, the main achievements are in the task 4.1 and 4.2. As a first step in work package 4, the relevant subsystems of the harmonized V&V simulation framework were identified, agreed on among the partners, and documented in deliverable 4.1. And these subsystems form the basis of the upcoming work. So the figure here on this slide shows a first structure of the V&V simulation framework. All the colored parts are subsystems of the simulation framework, and the parts in gray are necessary in or outputs or activities outside the simulation framework that will not be part of the work in work package 4. But more to this in a minute. And in task 4.2, a working document has been set up based on the relevant subsystems defined in task 4.1 and the use case requirements defined in task 7.1. And between the partners involved, an agreement on the requirements format and the level of specification has been reached to map the use case requirements to the subsystems. And this is work is currently ongoing and will then be reported in deliverable 4.2. So this is everything for a short introduction, and now we can continue with the main presentation for today about the relevant subsystems to validate CCAM systems.
Yes, thank you, Bernhard. So yes, good afternoon, and as already said, my name is Anders Thorsén, and I am a senior researcher at RISE Research Institutes of Sweden. And I have been a task leader for this task 4.1 in Sunrise, to identify relevant subsystems to validate CCAM systems. And not all project partners has been part of it, but a broad group has been part that cover all the aspects from research organizations to OEM. And I will start here with to show a picture that is actually newer than this task. This is this is a draft of the Sunrise Safety Assurance Framework. That was, it's not in the deliverable as it was not available at that time, but it shows it has the audit perspective, the scenario database perspective, the execute part, analyze part, in-service monitoring part, and also the requirements, the ODD behavior, external requirement, test objectives. And the focus for this task is on the virtual part. So I try to indicate that here, that the environment for allocation is done to virtual, and what actually is dealing with this task is the simulation framework to be used for the test execution in the virtual environment. So it's this small part that is in focus. And you already have seen the main part of this picture. For the subsystem overview. And to start with, we had to agree on what a subsystem is. And we chose a rather simplistic definition. A subsystem is a part of a subsystem, which itself is a system. This is a non-exclusive list. The gray boxes are not part of the simulation framework. On the input side, we assume that the subject specification is available. Test cases requirements are available, including that the scenarios to be tested are already allocated to the virtual environment. And output is identified previously unknown scenarios, test results, KPIs, test logs. And then we have the different subsystems that we have identified. And we should also say that this is a framework, and it should be versatile and adaptable for future technology development. Sunrise does not develop specific tools for this. We aim to use existing tools, and each subsystem could be different tools could be used for the same subsystems, depending on use case, the need, what the organization that is doing the simulation, what we have available. So it's a framework that should be adaptable depending on needs and what's happening in the future. To start with, we agreed that we need a test case manager. The main function is to interface with the rest of the safety assurance framework, orchestra execution of test scenarios. We included a box for SUTIF assessment to identify unknown scenarios, to compute KPIs and metrics, to check correctly execute test cases. And the composition is test scenario manager, data management, test assessment, SUTIF assessment, and system under test configuration manager. Secondly, we have the actual simulator part and the environment subsystem. Main function to describe the environment and to model the operational domain and operational design domain. Composition that it includes static environment and dynamic environment. And the dynamic elements are all movable elements in the of the ODD, though the behavior is controlled by other subsystems, the subject vehicle and traffic agents that we will see on later slides. So then the subject vehicle that we have divided into 3 main blocks: sensors, main function, models needed for sensors, composition, different sensor modalities, different model fidelities. Examples that could be model is radar, LiDAR, camera, with more. Then we have the AD function block of the subject vehicle. Main function is to control the vehicle's response. We have indicated that it's commonly divided in perception, planning, and control and act, but it's not a requirement. It's more an example. And the picture in the bottom left there indicates that the environment and sensor data and the ego sensor data goes into the AD function: perception, planning, control, and act. And then we have the vehicle actuation systems that is not shown in the subsystems. It's between the vehicle dynamics and AD function. And then the third part in the subject vehicle, the vehicle dynamics. Main function to describe the motion of a vehicle. Composition, it needs to include aspects like tire and brake dynamics, engine and powertrain management, aerodynamics, suspension, steering, and vehicle modeling. And it could be models with different fidelities. So what we include in the details is a trade-off between realism and simplicity needed for the actual simulation. Then we have the traffic agents. The main function is to model the behavior of all dynamic elements except the subject vehicle. Composition, it's described with the behavior models, and relevant states is communicated to the simulation environment. It could be position, speed, and etc. Then we put the connectivity in a separate subsystems. That could be discussed. It might overlap with some of the other subsystems, but we choose to do it as a separate subsystem with the main function to enable communication between subject vehicle and other vehicles, pedestrians, cyclists, infrastructure elements, and network services. Forcing composition that it should cover scenario module, onboard units, roadside units, and the communication network. And then we also decided to add a separate subsystems for simulation model validation with the main function to improve the quality of the simulation models. And it's indicated in the picture that we have physical tests outside the simulation framework from which we get results into this simulation model validation subsystems. So it should feedback results from the correlation analysis, check if additional physical tests or simulations are required, and provide proof of simulation accuracy. So the idea is to use this as a part of the simulation framework besides other model validation process needed to be done outside the actual runtime. We also try to summarize some more subsystem requirements on a general level. So the simulation validity is, of course, essential. Tool requirements, test automation tools will be needed for virtual validation. Part of this is the test case manager. And virtual models is needed with realism. To use it as a safety assurance framework, it needs to comply with safety standards. And to handle this, we probably will need also tools that's outside this picture, requirement management tools, data management and analysis tools, tools for version control, configuration management and reporting. Interfaces are indicated with these arrows of different colors. So the aim with this, when we define this simulation framework, was to aim for versatility, more focus on the information that need to flow than the particular interface and standard to be used. We encourage the use of open standards, but as much happens in that area, some examples is given in the report, but it's no pre-described requirements. It's examples that could be used as it is of the situation today. And then for fidelity requirements, of course, we need appropriate degrees of fidelity depending on the scope of the simulation and the requirements. So, trying to conclude, we have presented a non-exclusive list of subsystems that are identified by the task partners. Test case manager, environment, subject vehicle with sensors, AD function and vehicle dynamics, traffic agent subsystems, connectivity subsystems, and simulation model validation subsystems. The focus for this task has been on virtual simulation, but the safety assurance framework will also cover different types of XIL tests. So we foresee that one or more of these subsystems could be replaced by the actual hardware, for example. And the work presented has been mainly theoretical, but several participants are experienced in virtual simulation tools. So that was a summary of what's presented in the report. D4.1, report on relevant subsystems to validate CCAM systems. A draft version is available on the Sunrise website. You can see the link there, and there's also QR code giving the direction there. The version is still, it's pending approval from the European Commission. So it might be updates to it, but we hope that this draft version should be the final one. We expect to have it approved rather soon now, but we have to see. So thank you very much, and now we leave it open for questions from the audience, and that you could put in the chat. That's Julia previously described.
In the questions pane. So yeah, at the moment, we haven't yet received any questions from the audience. I leave you some minutes, unless our presenters have been extra clear. No questions so far. Okay. last chance for asking questions. Any aspects, our speakers, you would like to mention a specification on? Some extra details yourselves that you would like to add before we close the webinar for everybody?
Not from my side.
Okay.
No, I don't. Nothing that comes up in my mind either.
All right. We have one question. For each module block that you mentioned, sorry, what do you think is the current market of tools covering?
Yeah.
Sorry, Anders. May I hear some words? So this is basically a continuation of what we did in this task 4.1, which the work that Anders just presented. So is that we take these subsystems that we defined here, and we look at the tools and models that are available for those subsystems, which also fulfill the requirements that we have from the use cases. And here, it will be task 4.3. We will collect those tools. We will try to build up possible tool chains with a collection of tools, freeware and also licensed products that fulfill the requirements for each of the subsystems that we defined here. So this is more related to upcoming work, current work that we have in work package 4, but so far in this we don't have results in form of a collected list or a full list. So I would refer to the future of this work package for an answer for this. Anders, do you want to add something here?
No, I think that's yeah, that describes very well the situation. And yeah, if you look at the partners in the project, you can see that there is some partner that has their own tools also that obviously will want to use this one as, and while we as research organizations, yeah, we might look into open source tools, and yeah, so it will be a broad range of different choices, I guess, between the partners. And the intention with these subsystems is that it should be adaptable and possible to use different depending on your needs.
Okay, thanks a lot for both your answers. We don't have any further questions. So I would like to thank you for our speakers for their presentations, and our audience. We have our next webinar on the 7th of March. As you can see on the screen, this webinar, same timing, will be related to requirement for CCAM safety assessment data framework content. And we hope that you'll be joining us for that next webinar. The information for registration will soon be shared on our channels for the project. So stay tuned, follow us, and talk to you next time. Thank you very much.
Thank you.